talk about integral. Integral stands for a bunch of things, but mostly in this context, it's going to be area under a curve. Right? So you have a curve, blah, 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 from A to B. So we learned how to do all the approximating stuff. Now if you actually want to find the area, you do the integral from A to B of f of x dx, where that's f of x. Right? I did this the other day. So this integral, so that's a giant S, which stands for sum, but that's essentially doing the Riemann sum. Okay, so see right there if you want. You sure? We could all watch you walk across. The exercise in awkwardness. No? You sure? Alright, so this is antiderivative of f evaluated b minus antiderivative evaluated a. So the capital F is the antiderivative, so working backwards. So for example, if I wanted to find, so what's a good example? F of x equals 1 over x squared from 1 to 3. And I want to know, what is that area? Why would I care what that area is? I don't know. You want to know what the area is. Well, that. So that area, I now have to take the antiderivative of 1 over x squared. Well, that's the same thing in x to the minus 2, which is x to the minus 1 over minus 1. I use that little line to symbolize that I'm going to plug in 3, I'm going to plug in 1, and I'm going to subtract. So remember, x to the negative 1 is 1 over x. So this is negative 1 over x from 1 to 3, which is negative 1 over 3 minus negative 1 for 2/3. You're going to need that at some point, right? You're welcome. Okay? So that's what the integral is all about. And this is integral calculus, and you are going to spend basically at least half the course just learning how to do integrals. Okay, now, remember the integral stands for the area, so we could ask you stuff where you can't actually do the integration, but it's just fun with areas. For example, I give you something annoying like this. Let's say that is 1, 2, 3, 4, 5, whatever, 6, 8, and 1, 2, 3, 4. Sorry about the scaling in there. Okay? So you have some set of lines like that. It makes some obnoxious shape. And I say, what is the integral from 0 to 4? And this, of course, is s of x. So this is geometry class. So if I said, what's the area, the integral from 0 to 4, I'm looking for this area. Now, I know you can't integrate that function. It's a weird function. But of course, you don't need to integrate it. You want the area from 0 to 2 is going to be a triangle. Then that's a trapezoid and that's a rectangle. So let's see. I would have from 0 to 2 would be 1/2 base times height plus a trapezoid, which would be 1/2 sum of the bases times the height. So base of 3 and base of 2. You could, of course, break that up into a triangle, rectangle. And then a rectangle, which is just base times height. So let's see, that's 3 plus 5/2 plus 2 15 halves. So if I said what's the integral from 0 to 4, it's just 15 halves. So far, so good. Of course, I can make it harder. Get that out of the way. What if I wanted to find integral from 2 to 8? Well, that's the x. Yeah, take a minute to figure that out. That's an 8 if you can't read my hand, right? I'm going to do the integral from 2 to 8. What we're going to do is we're just going to add up all these different areas. So let's see. From 2 to 3, I did that one before. That's 1/2 sum of the bases times the height. So this is a trapezoid. That, right? And of course, you could cut it right here and make it a triangle or a rectangle if you wanted. Then I have this rectangle, which is a base of 1 and a height of 2. Then I have this trapezoid, base of 1, that's a height of 2 and a height of 1. Then I have, let's see, that's a trapezoid, base of 1 and a height of 1 and 4. And a triangle, which has a height of 4 and a base of 2. Okay? So again, first I've got trapezoid. So make sure you know the area of a trapezoid, right? It's 1/2 sum of the bases times the height. Okay? Because you forgot that. Area of a trapezoid. You average the two bases times the height. So you've got trapezoid here. You've got a rectangle here. You've got another trapezoid. Another trapezoid. And a triangle. And you add that up and you get 5/2 plus 2 plus 3/2, 5/2 plus 4, which is 5, 7, 11, 12.5, or 25/2. Okay? Anybody get 25/2? Yes. You two get A's. I don't even know who you are. Anybody else? Alright, you all get 20. You all get A's. So you don't go. Okay? Any questions? So now, of course, how do we make this more entertaining? I'll leave that for a minute, make sure everybody's got it. So you understand what I did. So when I'm doing the integral, all I'm doing is doing the area starting here, finishing there. And it's just the area under the curve. So most of the time, you don't get nice, easy lines, and you can't just divide it up geometrically. You have to actually come up with something complicated. That's why, you take this class, because you guys could all do triangles and rectangles. I hope. You can always cut them out, paste them, and measure them with your rulers. What if I give you a slightly more annoying picture? Something like that. Well, now notice, if the area above the curve is going to be a positive number, and area below the curve is going to be a negative number. Okay? So if you were finding the area, you get up to here, you found some area, and now you'd be subtracting from here. Okay? Pull that -2. Then you start adding again when you got to that area. Does that make sense? So if I wanted to find the area from 0 to 3, so f of x dx, very soon we'll be learning what to do with FDX. Well, that would be the area of this rectangle, that trapezoid, and that triangle. So this is 1/2 1 times 2. I lied, that's just 1 times 2, that's a rectangle. 1/2 height of 1, and the bases are 2 plus 4. And then a triangle 1/2 of 1 times 4. Okay, and that's 2 plus 3 plus 2 equals 7. So the integral from 0 to 3 is going to come out 7. But now what if I want to do the integral from 0 to 5? Well, we have a couple of things we already know from 0 to 3. Okay? So one thing you can do is you can say it's going to be the integral from 0 to 3 plus the integral from 3 to 5. And we already know the integral from 0 to 3. So notice, you can add those two integrals together. Now what is it from 3 to 5? Well, that's just base of 2 and a height of 2. So 1/2 of 2 times 2 is 2. But it's a negative number, so the area is 5. Somebody looks puzzled. To understand why you subtract, the area is below the x-axis. So area above the x-axis is considered positive. Area below the x-axis is considered negative. So you found this area up to 3, and you said that's equal to 7. And now you're going to subtract the area of that triangle. The area of a triangle is 1/2 base times height. 1/2 of 2 times 2 is just 2. So that's negative 2. Okay? Then if I went all the way to 7, well, this has also got an area of 2. So I'd be adding that back. So I get back up to 7. Yes? You could end up with a negative area. If you had a picture... Say you had something like this. Oops, wrong way. Okay? And this was, I don't know, let's make it up. Let's say that's 8 minus 20 and 4. Okay? And the integral from 0 to 2 would equal 8. The integral from 0 to 10 would equal negative 12, because it would be 8 minus 20. So you can get a negative answer. Okay? Negative, remember, negative in physics world, usually just means other direction. So, for example, if this was a velocity curve, this area would represent the distance traveled in a particular, well, usually time. So if this was how fast something is going, and this was the time in, say, minutes, in 10 minutes you know it's gone negative 12, which means it's gone 12 to the left instead of the right, or down instead of up, or something like that. Okay, so negative, that isn't necessarily bad. If that's your bank balance, it's bad. That's when you call mom or dad, right? Dad, mom, whoever's easier. Right? Grandma. Alright. I used to do a lot of begging. You know what the trick is. You say you have to buy another book for class. Really expensive. Right. Then you download the PDF. I am posting the homework pages. I hope you know that I'm not dumb. I recommend, since I'm posting the homework pages, you go out and buy a used, previous edition of the book for like $8 from Amazon. Okay? Don't go out and buy a brand new copy of the book. It's not necessary. Okay? For those of you who have not already illegally downloaded the PDF, which I can't tell you to do because that's illegal. Okay? We didn't have those when I was in college. We just invented books. We used to write on rocks. It was very complicated. We kicked dinosaur blood and then it would dry. If it rained, it was terrible. You lost all the stuff. But then we discovered fire. It was easier to write indoors. All right. Anyway, so you could get a negative area. If you could stop in the middle. You could do all sorts of things. So, for example, say I asked you, what's the maximum area? Well, at this point you're at 8. Then you're subtracting. Then you get back up to here. So the biggest area you're going to get is 8. So if this was something where I said, what's the maximum total distance or something, it would occur at x equals 2. Okay? If I said, where would the minimum be? The minimum would be here. Okay? At x equals 10. So we could ask you something annoying like that. How are we doing in these so far? You took the AP. They have lots of these on the AP. We love these questions. I don't know why. So here's a variation on it that I also would concentrate on learning. Oh, so before I forget, so we're learning stuff today. We're learning stuff on Monday. And Wednesday, about halfway through, is going to turn into a review session for the midterm. And all of the following Monday will be a review for the midterm. Okay? I'm giving you about 2 hours worth of review. I hope that's okay. I'm not going to be able to have time for a special review session, so these will be reviews. Okay? Sorry about that. You can blame the snow gods. Okay. So let's say this curve is f of x. So this is what's called an accumulation function. Accumulation, as in to accumulate, to add up. Okay? And what happens, what does this mean? This means find the area from 0 to x. So g of x means find the area from 0 to x underneath the curve f of x. So, in other words, you just keep going to the right and you stop at x. So g of 5 would be the area from 0 to 5 of f of x dx. If you have a homework problem that looks like this. If you don't, you will. Okay? I can see in the future. Okay? So g of 5 would equal 8. Okay? Because what does g of 5 mean? Well, remember x is g of x, right? So we go from 0 to 5 of f of x. Okay? You really want to avoid confusion. You change that letter. It doesn't really matter, okay? You can make it T, you can make it banana. Alright, so the area, so this G tells us what the area is. So if I wanted to find G of 10, the integral from 0 to 10 of f of t dt, that would be plus 8 minus 10 equals negative 2. Okay? You understand why that's negative 2? I mean, you're just adding the areas. Okay, and if I said, what's g of 12? The integral from 0 to 12 of f of t dt, which would be 8 minus 10 plus 6, which is 4. So now what if I said, what is the maximum? Where is the maximum? What value of x is the maximum? 5. At 5. Because that's when you had the biggest positive area. Now you subtract. And even though you add 6 back later, you don't end up with as big a number because you subtracted more. Okay? If this was 16, then you would end up with a bigger area when you got out to 12. Does that make sense? I'll say it again. So right now you have 8 minus 10 is minus 2. When you add 6, you get 4. If this was big enough, it was like that, then this would be where the maximum is. Okay? The minimum would occur at 10. Okay, good. Where is g of x increasing? Sure you want to go for it right away. So let's think back to 125. When a function's increasing, what do you know about the derivative? Love to hear that. Okay? The derivative is positive. Okay? So if g of x is the integral of f of t, what do you think the derivative of g of x is? It's just plain old f of t. Okay? Because the derivative and the integral sort of wipe each other out. We're going to learn more about that in a minute. Okay? Or if you just think about the area is increasing all the way until you get to 5. Then the area starts to shrink. And the area will decrease all the way until you get to 10, and then the area will increase again. So it's going to be increasing on 0 to 5, and 10 to 12. And it's decreasing on 5 to 10. Make sense? Who's lost? Who's lost? Nobody understands that. Wonderful. Makes me very happy. I don't have to teach it twice. Alright, so this brings me to something called the fundamental theorem of calculus. A very scary sound. But that has to do with the relationship between derivatives and integrals. We'll come back to more of this. Okay. So the fundamental theorem of calculus sounds so important. It's fundamental. This is one of these things that Newton discovered. And Newton found that there is actually a relationship between derivatives and integrals. That's the whole antiderivative thing. So we're going to learn how to find the derivative of an integral. Okay? So for example, let's say I told you that f of x integral from phi to x sine t dt. And I want to know, what is f prime at x? It's really easy. You're doing the derivative of the integral now. So you're not doing the antiderivative. You're just doing the derivative of the integral. So you're doing the derivative of the antiderivative. So this just comes out sine of x. That's it. No plus c, just sine of x. Now why is that true? Well, let's do this out. First, the integral from phi to x of sine of t dt. Well, remember what the antiderivative of sine is. It's minus cosine. The derivative of minus cosine is sine. We're going to go from phi to x. So that is minus cosine of x, minus minus, so plus cosine of phi. What's the cosine of phi? I have no idea, okay? But it's a number. It's a constant. Okay? So when I take, now I'm taking the derivative, because now this is f of x. So f prime of x is take the derivative. What's the derivative of minus cosine? Sine. And what's the derivative of cosine of 5? 0, because cosine of 5 is a constant. So you end up right there. Okay? That'll lead us to a rule. Derivative, integral from any constant, x, f of t dt, is just f of x. And that is the first fundamental theorem of calculus. Yes? Here, first I took the antiderivative, then I took the derivative again. So I took the antiderivative, and what happened was the bottom number just comes out a constant. So when I take the derivative of that constant is 0, and it just get back where I started. But now, instead of t, I have x. Okay? So if I go from any constant to x of f of t, I just end up with f of x. This could be a billion, it could be negative a billion, it doesn't matter. It could be pi, if you really want to mess with your head. Okay, or e cubed, if you really want to mess with you. It doesn't matter. Okay? Because it's a constant. So, and this just means derivative. So if I had the derivative integral from 3 to x, e to the t squared dt, that just becomes e to the x squared. Notice, no constant, yes. Where did the t go? Where did the t go? It got replaced by x. Because here, right, this was cosine of t from x to 5. So I plug in x for t and I plug in 5 for t. So these are what are called dummy variables. It doesn't really matter what the variable is. Okay? So it can be very confusing. Also, do not confuse this with finding the integral, which people often do. Here you are finding the derivative of the integral. It's like doing the square root of the square. Remember all that inverse function stuff we did last semester? You're kind of doing that. Okay? Fortunately, we're not doing the whole f inverse, f blah, blah, blah. Okay? Because that's painful. And teaching that to my other course very soon. You're done with that forever. Forever. Okay? So that's called the first fundamental theorem of calculus. So if you want to find from 3 to x of e to t squared, it would be that. If this was 30 to x, it's the same answer. Okay? If this was negative 30, it's still the same answer. It doesn't matter. Now, of course, I have to make this harder. I couldn't just stop here, God forbid. Suppose I had f of x equals the integral from 5 to x cubed of sine of t dt. It's not really much harder, just a little bit. But you know why we make these harder? We don't really like you guys very much. That's why. I pretend I do, but the truth is I live to torture you. It's just a happy day when you're suffering and crying, you know, and all that. It's just, oh man, it's wonderful. Anyway, why do we make it harder? Because otherwise you'd all get A's. You can't have that. So, this is just what you did before. You want to find the derivative, f prime of x. Would be you plug in the x cubed. And then you use the chain rule. What's the derivative of x cubed? It's 3x squared. So multiply it by 3x squared. That's not so bad. Why? You guys want to know why? I want to make sure you understand. Let's do a why, okay? I know how important theory is for you guys. As I said, there's a little bit of a chain rule involved. Or we can see by doing it out. So remember before, we want to do the antiderivative, so we're going to do the integral of sine of t. That was minus cosine of t from 5 to x cubed, which is minus cosine of x cubed plus cosine of 5. Now, I'm going to take the derivative. What's the derivative of minus cosine of x cubed? it's sine of x cubed times the derivative of x cubed. So that's where the chain rule comes in. Okay? So now the sort of fuller version of the first fundamental theorem of calculus. I'll make that a G. This becomes f evaluated g of x times g prime of x. So again, it's not really very hard, but let's... So suppose I wanted to find the derivative of that integral. There's a prime here, it's kind of hard to see. Well, you plug in the sine x wherever you see t. And then, since sine is a function, you multiply by the derivative of sine. That's it. We don't care about the 8. Good? I can make this, of course, slightly more annoying. Say I wanted to do derivative integral from 5 to sine of x Now what happens? Do I have to do I get 2 rounds of sine in there? What happens? This would become the derivative of that. It would be the square root of sine squared x plus sine cubed x times cosine x. Okay? How are we doing on these? We don't like? Why not? It's not that hard. It's just plugging in and doing a little derivative stuff. Believe me, you're waiting for this to get worse. It doesn't get worse. Yes?
Well, can you do that again?
I can't hear you.
Can you do that again?
Surely.
Please.
I'm taking the derivative of this. So where I see t, I'm going to plug in this function. Okay? And I'm going to multiply by the derivative of this. Because it's chain rule. Okay? That's all I'm doing. So that's the rule. You take t, replace it with whatever the function is, and you're going to multiply it by g of prime of x. Okay? There's only one more flavor of this that's just slightly harder, but not really. Suppose I had another function down here. Now what do you think I do? I'm going to erase this. This was actually on my midterm last year, this exact problem. My midterm, which I'll post in about a week. So we'll make some samples. After we've written the midterm, we'll get you guys samples. So no reason to disappoint. Alright, so wherever you see t, you're going to plug in sine x, and then times the derivative of sine, minus, now do it to the bottom. Plug in cosine, times the derivative of cosine. And you're done. Okay? That wasn't so bad. Sorry? Oh, I'm going to do a couple of these now. You guys ready? Let's give you 3 practice problems. Okay, why don't you try those 3 variations? Okay, so this is, each time, find f prime of x. I should write that somewhere. I'm going to do just the derivative of that integral. We're just going from 4 to x. You just plug in x. Square root of 1 plus x squared. You get that one? So far, so good? Medical school? Maybe. Alright. What if I have x cubed? Well, wherever I see t, I put in what x cubed. So it's the square root of 1 plus x cubed squared, which you could make 1 plus x to the 6th if you wanted to show off, but it's certainly not necessary. And I always say, don't show off unless you're going to get it right. How we do it? Medical school. Okay? Med school. Third one you definitely get to med school. No doubt. I'll just call them up right now. Alright. But wait, I forgot something. No med school. Funeral parlor. They gotta be dead first. Then you can worry, then you can do all your work. Alright, so I forgot to multiply by x cubed. There you go. There you go. Alright. Don't show off until you can get it right. You know that joke about the funeral. Never mind. Anyway. Right, okay. You can't mess it up. You know what I mean? Alright. So, you plug in x cubed for t, and you get 1 plus x cubed squared, and then you multiply by the derivative of the power. You multiply by the derivative of that. So now for the hard one, we have to do it twice. That's all. So this becomes the square root of 1 plus x cubed squared times 3x squared minus the square root of 1 plus x squared squared times 2x. Okay? Happy so far? How do we do on those? Question. Why is it minus? It's the integral of the top minus the one on the bottom. Why are we able to do that? What you really do is you pretend that when you're doing the integral from x squared to x cubed, you really do the integral from x squared to some constant, the integral from some constant to x cubed. Okay, and you chop it up in the middle. Okay? And since the part with the constant goes away, that's why you're able to do this. Okay? But that's not important. How do we like these? They're not so bad? They're really not that hard. You just follow the rules. Okay? Now what else could we ask you to do? Well, we could just ask you to find some antiderivatives. Ooh, that was nasty. So I did some of these the last time, but I'll do it again. Let's practice just a bit. Remember how to do that? Can you read that? I'll work on some darker chalk for next time. I'm not making any promises. The integral from 0 to 1 with x cubed plus 4x squared plus 5. How do we do this? You take the antiderivative. Antiderivative of x cubed is x to the 4th over 4. The antiderivative of 4x squared is 4x cubed over 3. And the antiderivative of 5 is 5x. From 0 to 1. Plug in 1, plug in 0, and subtract. This would equal 1/4 plus 4/3 plus 5 minus, well, everything on the right side is just about 0. So you get 79 over 12. You guys know how to add something like 1/4 plus 4/3? What you do is you multiply 3 times 1, you multiply 4 times 4, you put the 4 and the 3 together. So 3 times 1 is 3, 4 times 4 is 16, 4 times 3 is 12, so you get 19 12. Okay? If you never learned that trick before, that's the way you combine the fractions. Very fast. You want to combine 2/3 and 4/5. That's 10. That's 12. That's 15. You get 22/15. Your teachers never teach you that? No. That's because you're young. If you were old like me, you would learn that. Okay? Works every time. It also works with subtraction. So if you had 3/8 minus 1/7, it's 21 minus 8 over 56. It's just 13 over 56. Okay? That's how I do it so fast in my head. That's all you have to do. Wow! How come we never learned that? Call up your 5th grade teacher and ask if he or she knows it. And they'll probably go, I don't know that. Is that going to be the test? Well, this might be on the test. Okay? And I don't know if Professor Tanase expects you to be able to do the fractions or if you can leave it there. I let you leave it there, but she may feel otherwise. Okay? She probably agrees with me, but you never know. But you should learn this trick anyway. It's very handy. Do it at parties. People have trouble sleeping. It works really well. Okay? It's not so good for the dates, but that's okay. All right, let's see if you can do another type of integral. I'm taking this directly from the book, so it's slightly nasty. It's not my problem. How do we do this one? Factor out the half. So now we have 1/2 the integral from 1 to 9 of 1 over x dx. Okay? And what's the integral of 1 over x? Ln of x. Ln of x. Ln. Pronounce log. Ln of the absolute value of x. From 1 to 9, you got that half outside. So that's 1/2 log 9 minus 1/2 log of 1, and the log of 1 is 0. So it's 1/2 log 9, also known as the log of 3. Okay? Either answer would be fine. You know why it's log of 3? You put the half back up, and that's the square root of 9. Square root of 9 is 3. So you do problems like this in the book, and you get to here, and you don't understand why they have this. They do that just to show you that they're nasty. Okay? So you guys are getting the idea. This is all fundamental theorem of calculus stuff. Mind the way? Okay? This is good enough. You can stop here. You don't need to do that stuff. Alright, so again, so you pull out the half, because remember, 1 over 2x is 1 over 2 times 1 over x. Okay? So now you got a half. The antiderivative of 1 over x is natural log of x. You don't really need the absolute value because 1 and 9 are both positive. But you should do it just for practice. Okay? Back to the good stuff. Oh, there is one other little thing I haven't shown you guys. It's not complicated.
He's not gonna like make it.
It's actually very straightforward, but might as well teach it to you.
I'll go with it, but I don't.
Alright. And the integral from a to b of f of x dx, and that's equal to some value k. And what about if you go from the other direction? If you reverse, or these are called the limits of integration. So instead of going from a to b, you go from b to a. What happens to k? You get negative. Good. You're just going the other direction. Negative k. Did I do this already? I forget. So, suppose I gave you the following. Okay. The integral from 0 to 10 of f of x dx is 25. And the integral from 4 to 10 of f of x is 13. What is the integral from 0 to 4? 12, right? Because all you'd really do is you'd say, the integral from 0 to 4 plus the integral from 4 to 10 is the integral from 0 to 10. Okay? Not so bad? So the integral from 0 to 4 is what we're looking for. The integral from 4 to 10 is 13. The integral from 0 to 10 is 25. X would just equal 12. So far, so good? Now I could make that from 4 to 0 instead of from 0 to 4. Then your answer would be negative 12. We liking this? We're not. This is not so bad. This is, believe it or not, this is the theoretical part. This is the abstract part. We're going to start to get much more mechanical in a while. I know you're going to like that better. You're going to say, whenever I see something, what do I do? Okay? Do we have questions on the homework web assigns that are things I haven't covered today? That was the idea, was we're going to sort of catch everything up. I'm sorry? Well, I haven't memorized what they are. I don't know what the last 3 questions are. From the book. Page what? Yeah? What about it? Oh, right! That's good. I'm glad you asked that. Suppose I get this I put in my notes that I put up on the blackboard, but obviously for the 3 of you who looked at the notes, it's not a problem. For the 227 of you who did not, and I wonder why no one likes it. Okay, so, if I wanted to find the limit as n goes to infinity of sigma I equals 1 to n of I squared I cubed over n to the 4th. Okay. That is an integral. That is going to be the integral from 0 to 1 x cubed dx. How do I know? Okay? Well, first of all, they tell me it's on the interval 0 to 1. Okay? So that tells me, this says it's on 0, 1. This was homework problem 75. Okay? But, you know, you have to be able to do all of them. So I'll just do an example of one, like this one. So the 0 to 1 tells me I'm going to integrate from 0 to 1. Okay? This tells me what my function is. You see I cubed? It's x cubed. If it was I to the fourth, it would be x to the fourth. If it was I cubed plus I squared, x cubed plus x squared. From here, you should be able to do the integral on your own. Okay, so if I had that would be from 0 to 1, x cubed plus x squared. Okay? Yes? Well, this is the Riemann sum, okay? So if you evaluate this, it's the same as evaluating that. That's what I was sort of showing last Wednesday, which no one in the whole room was getting. Okay? So the n goes away because you're doing the limit. If the limit goes to infinity and you evaluate all of that, you'll be doing the same thing as evaluating this integral. Okay? This is the connection between those sums and the integration. When you go to infinity, those sums vanish and turn into the integral symbol. Yes? Well, it says it's on the interval 0 to 1. If you look at the problem. Okay? I'd have to give you an interval. If it was on 0 to 2, then this would be from 0 to 2. Okay? But then that would become 2 I cubed over n squared. So it's going to get messy, so I don't want to overcomplicate things. Alright, so study hard. Monday we're going to do some new stuff. Look at what I put up on Blackboard. It's actually useful.